friends, my name is Shashank and welcome to my channel Code with Shashank. The agenda for today's session is linear regression. In subsequent lectures, we are going to look into the theoretical part of linear regressions, cost functions, gradient descent models, and then we will look into the practical implementation of linear regression via Python models. Machine learning is basically classified into three main types: regression, classification, and clustering. In a regression problem, the output variable to be predicted is continuous in nature. For example, sales or salary we wanted to predict. Whereas a classification is a kind of problem where the output variable to be predicted is in categorical in nature. For example, we wanted to understand the sentiments of a paragraph, whether it is going to be a positive sentiment or negative. So we are having two classes, positive or negative, which are categorical in nature. Whereas a clustering is a kind of unsupervised learning where we don't have any predefined label. So no predefined label is allocated to a group of clusters. In today's session, we will be focusing on linear regression. So what are linear regressions? We understand what is the kind of regression problem is. Linear regression is categorized into divided into two main kind of problems: a simple linear regression and multiple linear regression. A simple linear regression is a kind of problem where the model have one independent variable, whereas the multiple linear regression is a kind of problem where we have one or more independent variables. Let's look into this graph. This is a kind of simple linear regression problem where we wanted to predict the sales based on the marketing budget we are spending on TV. Right? So this is a kind of simple linear regression problem. A simple linear regression problem can be written as h theta, which is the predictive value y pred, theta naught plus theta 1 into x, and can also be denoted as beta naught plus beta 1 into x. If you look into various logs, right, you will find a different notations for that, but all in all are the same. Basically, in simple linear regression, our goal is to find the best fit line, which we will calculate with the help of residual. Residual is basically an error which is denoted as EI, and which is the difference between y actual and y pred. The purpose of simple linear regression problem is to minimize the total error sum via ordinary least square method, also known as residual sum of square, which is equals to E1 square plus E2 square till all the points, and E1 is equals to the difference of y actual minus y pred. So if we look into this, the cost function for a simple linear regression problem can be denoted as 1 by 2m sum of y pred minus y whole square. So what we are basically doing, we are taking the difference, squaring it out, and we are doing the sum of it. And we wanted to minimize this sum in order to get the best fit line. Let us understand the cost function and what are the methods that we can use to minimize the cost function to get the best fit line. As we mentioned, the cost function can be denoted as this formula: g of theta naught theta 1 equals to 1 by 2m, n equals to 1 to m, where m is the number of training examples, y pred minus y whole square, and can be further written as, since y pred will be beta naught plus beta 1x, we can further written the same equation into this form. Let us take an example. Okay, we wanted to estimate the salary based on the experience. This is our given data set. When we plot a diagram between experience and salary, we can get this straight line. And these are the actual points, and this straight line are the predicted values. Our aim is to minimize the cost function in order to get the best fit line. And in order to minimize the cost function, there are certain methods that we can use. For this particular kind of linear regression problems, we are using the unconstrained minimizations, where we will be using the different methods like differentiation, gradient descent, and for the normal equation, we can also use this formula in order to get the coefficients. X transpose into X, inverse of that into X transpose dot Y. We will look into that in details. Basically, the intercept, it is also sometimes called as the constant in a regression model. It represents the mean value of the response variable where when all of the predicted variables in the models are equal to 0. Now let us look into the differentiation method, which will be used to minimize the cost function in order to get the best fit line. A cost function can be denoted as j of theta naught theta 1, which can be written as 1 by 2n sum of n equals to 1 to n, where n is basically the number of training examples. Ypred, which can be expressed as beta naught plus beta 1 x, is a linear equation, minus y, which will be actual value, whole square. When we take the partial derivative of this equation in terms of m and c, where m is basically the beta 1 and c is basically the intercept c, okay, beta naught, we will get this equation. When we take the derivatives in terms of m, we will get this equation. When we take the derivative in terms of c, we will get this equation. After taking the derivative of whole equation, this whole equation in terms of m and c, we will get this results. An example in order to understand the differentiation method more precisely. Suppose we wanted to predict the salary based on the experience. In this data set, let's consider the experience has independent variable x, whereas the salary, which will be denoted as y, we wanted to predict it. This equation can be written for this training example in this form, where ypred will be mx plus c minus y whole square, and 1 by 2n will be 0.0625, where we have 3, 4, 5, 6, 7, 8. 1 by 16 will be 0.0625. So j theta naught theta 1, this equation we have written it in this form. And when we take the partial derivative of cost function with respect to m, we will get this equation. And when we take the partial derivative of cost function with respect to c, we will get this equation. And when we solve these two equations, we will get this values where we will have the best fit line, where we will have c equals to 6238.0 and m equals to 1.0661.990. Okay, so we can validate the results. We can validate the value of c and m with the help of other methods as well that we will see in the subsequent lectures. And also we will going to validate the same results using practical implementation in Python using linear regression and OLS method. Let us look into another way of solving this equation using the matrix multiplication, where we will be deriving the value of theta naught and theta 1 with the help of this formula. XD will be denoted as the transpose of matrix X. This is the matrix X. The transpose of matrix will be this one. into x, and after that we will be taking the inverse of this product and we will be multiplying it with x transport, and then we will be multiplying it with y. Once we do this thing, we will get the same result. X naught will be the constant value and x1 will be the m value, slope value, which is this, and which we can see that it is same to that of the equation that we get from the differentiation method. In Python, in order to take the transpose, we have this method x dot t. For taking the multiplication of two matrices, we will be using the NumPy library, and we can use this function np.mat_mul, and we will be passing the parameters in order to get the results. Whereas in order to take the inverse in Python, again we need to use the NumPy library, where we have this function np.linalg.inv, and we will pass the matrix for which we will be taking the inverse. After computing the results based on this formula, we will be getting the same values. Now so we have completed two ways in order to derive the values. One is differentiation method and another is the matrix multiplication methods. We will look into the gradient descent method in subsequent lectures, and after that we will look into the practical implementation of linear regression method using Python libraries. Till then, I will take a break. Thank you all.